number 1? 5. Perfect. All right, if I were to distribute that, would I get the same thing back? Yeah. All right, what about number 2? What number do they both have in common? What? Oh, negative. Why am I taking a negative? Because what, Andrew? Not because they're both negative. Because the leading one is negative. Very good. So what number do they both have in common? -6. And then do they both have a letter? Yeah, what letter? X. All right, so what's -12 divided by -6? 2x. And then -6 divided by -6 is a positive 1. All right, y'all keep going. Keep going. See what you got. Yeah. Standard form. Couldn't have fractions. Couldn't have a leading negative. Couldn't have a DCF over the 1. Taking out the DCF, and we need to take out the negative. Number 4. Gosh. Like number 4? Number 4? So what would you take out there? Unity? How much? Not just 18. 18 eggs more than that. 1. There you go. Perfect. 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 So this is negative. You can't have a negative. So you're going to take 18 eggs and what you would take. It's those options. All right, what about number 3, guys? What did y'all get on number 3? Number 3. Yeah? Parentheses, yeah? Yeah, right cubed. -5. Very good, very good, very good. Alright, so since number 4 had a leading negative, what should we take out? Very nice. Very nice. Alright, what about number 4, guys? What was the GCF on number 4? How much? Negative 18. But why negative? There you go. Negative 18. Alright, what letter? X. Okay, so what's negative 36 divided by negative 18? Positive 2, and you have one X left with it, right? Because you had two X's, and you only took out one of them. Alright, what's 18 divided by negative 18? Minus 1, and what happened to the X? There you go. He went to the front. Y'all okay? Alright, what about number 5? There's just 3 of them. Don't worry. What's the number? 8, 16, and 8. What number? 8. Alright, now look. Here we go. You got 9 Y's. You got, or not Y's, X's. You got 4 X's. And you got 3 X's. What's the biggest X that goes into all 3 of them? 3, right? Okay, so we're going to take out 3. Okay, so you did 8 divided by 8. How much is that? 1. You had 9 X's. You took out 3 of them. How many do you have left? 6. All right, what's 16 divided by 8? 2. You had 4 X's. You took out 3 of them. How many do you have left? How many? 1. There you go. All right, what's negative 8 divided by 8? Negative, I can't hear you. 1. There you go. You just got to speak up, guys. All right, and then you had 3 X's. You took all 3 to the front. So you just close your parentheses. All right, same thing on number 6. Yes, ma'am.
Why did the Brady's comment next to it?
Okay, because you have 9. Like say you have $9. Say Keontae has $4, and say I have $3. All 3 of us could go to the store and buy something for how much money? How much do we all $3? Because this only has $4. He doesn't have 9. This only has $3. It doesn't have $4, and it doesn't have $9. So it's kind of like the opposite of what you would think. It's the smallest. You're not dividing in it. It's like you have 3 different X's all by themselves, and then 4 different X's. All right, what about number 6? What's the number that divides into all 3 of those? 5. All right, do they all have an X? Yes. X to what power? 1. Very good. Do they all have a Y? No. So this last one doesn't have any Y's. All right, 5 divided by 5. 1. Everybody together. How much is 5 divided by 5? 1. And then how many X's do I have left? 2. How many Y's do I have? 2. What's 10 divided by 5? 2. How many X's? 1. How many Y's? 1. What's 25 divided by 5? 5. How many X's? 0. None. Right, y'all okay? All right, here we go. Number 7. Yes, ma'am. You certainly could. Yes, ma'am. You could just put X squared. All right, here we go. 576. Do you remember all those perfect squares?
Yeah.
I can. Math workshops are on the table up here, okay? All right, so 576. You have to pick the biggest perfect square that goes into 576. What was the biggest perfect square? 24 is not a perfect square. Oh, not 576. I'm sorry. 768. I was looking at the wrong one. You are correct, though, on that one. 768. What's the biggest perfect square that goes into that one? 27 is not a perfect square. 256? Does that go evenly? Ooh, yes it does. All right, so look, several of you did 64. 64 does divide. Here's the only problem. Look at 12. What perfect square still divides into 12?
4.
So that's how you know that 64 wasn't the biggest one, okay? So we're going to do the 256. And then 256 times 3. Did I change the meaning? Do I still have 768? Yeah, it's just 256 times 3. All right, what was the square root of 256? 16. Should the 16 have a square root on top of him? No. So don't touch him. Don't take his lunch money. Don't beat him up in the hallway. He's fine. Don't mess with him, okay? Because a lot of you will try to change that to 4, and don't do that, okay? What about 576? He's already special. He's already just 24 because he was one of those numbers on that list. Do y'all understand why now I was emphasizing so much and gave you a quiz on perfect squares, then gave you a test on perfect squares? Y'all see why it's so important? Okay, so we're going to have math workshop test next week. Do y'all realize we only have 2.5 weeks left of the quarter? That's it. You don't want to talk about it? Why? It's stressful? Well. Well, speaking of tests, yes. So the reason I haven't given you a new calendar is because I didn't want you to freak out. Because on the calendar, it says we were supposed to have a test today. Okay, we're not having a test today. We are 2 days behind because we were out for 2 days for the storm, right? So we're 2 days behind, and today is Tuesday. And we were supposed to have a test today. When is your test going to be? Thursday is 2 more days, right? So today we're going to finish up and review. Tomorrow, what do you think we're going to do? Study guide. I'm going to get you the last page. Today I'm going to copy it and give it to you tomorrow. And then Thursday is what?
Test.
Chapter 2 test. Next week. Just the part we haven't tested on yet. Next week, we will have a math workshop test. Okay, I'm not 100% sure about the day yet because we've got to kind of fit some things in from being out for 2 days. So here's what we're going to do. We are going to do some problems together, and then we are going to get with our partners and work out a bunch of stuff together. So can anybody refresh our memory about what we learned yesterday?
We learned about, what's it called? Horizontal vertical.
What kind of functions?
Like parent functions. The type
Parent functions. We learned about parent functions yesterday.
There's a constant one.
There's constant and absolute value and linear and identity, right?
Exactly.
All right. What else did we learn yesterday? We learned how to graph them, right? We learned how to actually graph them on our calculators. And then there was one more thing that we learned about yesterday. We described them, right? Where we wrote down everything that happens to them. Still okay? All right, so let's go over. Your homework for last night was just page 30, right? Okay. Y'all okay? All right, so what does this tell me to do right here? Down 4. Is it being dilated by anything? Is anything going to make it stretch vertically or stretch horizontally? Anything? All right, so then how do I graph? How do I get all the extra dots? Out 1 and over 1, right? What if it had been, what if there had been a 5 right here? Stretch which way? It would be dilated, but how would I get my dots? How much would I still go out? If there, let's just say there was a 5 here. Let's say it was this. Oh, not over 5. What's the x value I would plug in? 5's already there. What's the x value I would plug in? 1. So I'd go right how much? 1. And then the y value would equal what? 5. So you would go up 5. So look, if you plugged in 1 is your x value. And then absolute value of 1 is 1. Times 5 would give you y equals 5. So your y is what you would go up 5. Okay? All right, what about number 3? Where am I going to start at on number 3? The origin, because you're not adding or subtracting anything. And what's this guy right here do? It reflects it. Do you remember where the button was that we hit on our calculator? The only time we hit that button was when the negative was in the very, very front. Which negative? It's the one at the very bottom down there by the decimal and the 0, right? So is there a number that I'm going to make it go out or up more? No. So what's the negative? Yeah, so what's it tell me to do?
Go down.
down.
Go down how much? 1. And out how much? 1. See how it got flipped over? What flipped it over again?
The negative.
The negative in the front, right? All right, one more, number 4. This is what your homework was last night. Okay, where does this guy tell me to go?
Down.
Inside.
Go right.
Inside, you move left and right. Opposite sign would be right too. Oh crap! I didn't mean to put my dot there yet. And then what's this guy tell me to do? Up 3. Then you put your dot when you're paying attention to what you're doing. All right. Is there a number in the front that's going to dilate it any?
No.
Nope. So what am I going to do?
Go up and
Over and out 1. There you go. Or over and up 1. There you go. Are y'all okay? Yes? No? All right. Do you see your partner? Are you looking at your partner? All right. Before you go to your partner, let's look on the board real quick. We're going to do all of page 31. Oh my gosh, there's a whole 3 problems on page 31. Woo, woo. It's going to be horrible. I don't know how we're going to do it. So you got all of 31. 32. What in the world does it mean omit number 12? Don't do it. Don't do it. Don't do it. All right, now look. Our problem on page 32 on our tests and on our quizzes has been that we do not slow down and read the directions. So make sure you slow down and read the directions. It has been everybody's downfall. You're trying to go too fast. Are y'all okay? All right, find your partner. And we are on 31, page 31 to page 34. Find your partner, go. Two homeworks from yesterday that don't have names on them. So if they're yours, please put your name on it and put it back in the tray. Page 23 and 25. Yes, ma'am. There's also a checkpoint here with a name on it. Okay, so put your name on it.
Hey, this last minute? Yeah. This last minute, that's still recording.
Alright, Jared, how you doing, bud?
Good.
Good? How we doing? Yeah. So, altogether, what would you do? Start zero, and then here, start zero. From there. This guy right there, your son. So it's gonna flip it, right? You go out, up, out. It's just like we did in the piece. So it's just gonna pull it up 3 things. Yeah. Because this you went right 2. You plugged in 2, 2 times 3 is why you went up 6. Now you gotta do the other side, which is the beach. Yeah. So this is multiply. Multiply. That's either gonna stretch it up further, or it's gonna pull it out further. So it's either gonna be skinnier base or wider. Okay? So you just have to be This guy had to do that.
This one doesn't have anything. Right, the 3 is going to tell you that it's a 4 up. We're not going to go out plus 4. We're going to go out one. Okay. We're going to go out 2. 6. Go out 2. 6. Now that push goes up. Right. This stretch takes away. First, right? And if they got wider, they stretch it. So this time we go out.
All right, what about number 5, guys? Get it? 5, guys. You can tell I'm hungry when I start making jokes about food. All right, number 5. So we're going to go to the origin, right? And what's this guy tell me we're going to do? You can go left 1 and down 2. Is there any number that's dilating? Is there anything pulling it up more or pulling it out more? Any number? No. But what's the negative do? So instead of going out 1 and up 1, I'm going to go out 1 and down 1. There you go. And then out 2 and down 2. That's good enough. So see how it's flipped upside down? All right, what about number 4, or number 6, excuse me. What's wrong? Sir? He told you wrong and you were right? Cheating. Joseph, are you okay on what we did there? Okay. Yes, ma'am. You didn't go down 2. Looks like you went left 2. So you should have, this told you to go left 1. From the origin, you should have went left 1. And then this guy told you to go down 2. Yeah, you just switched them backwards. You okay? Joseph, you okay? I mean, not Joseph. Jonathan, sorry. You okay? Okay. All right, what about number 6? Do you have anything that you're adding and subtracting back here? So where am I going to start? The origin. But now I have a number that's going to dilate him, right? So if I were to plug in 1 for my x value, what would be my y value? What's 1 times 3? 3, so I'm going to go up how many? 3 on both sides. All right, what comes after 1? 2. So if I were to plug in 2, that means I'm going to go right 2. But what's 2 times 3? 6. So I'm going to go up 6 on both sides. Alright, just for giggles, let's do one more. What's the next number I would plug in? 3. So I'd go right 3. And what's 3 times 3? 9. Do I have enough room? 7, 8, 9. Oh, yeah, I do. Same thing on the other side. Alright, so if it wanted you to describe that, what did that 3 do? He stretched it where? There's only 2 ways that he could stretch it. What's that called? What's it called? Vertical. There you go. We stretched it vertically. Alright, number 7. Don't let number 7 throw you off. It's the same thing, guys. Where are you going to start? The origin. What's the first number I could plug in? So I'm going to go right 1. And what's 1 times a half? A half. What's the next number I can plug in after 1? 2. So I'm going to go right 2. What's 2 times a half? 1. I hope that you're with me and not doing other things. What's the next number after 2 I can plug in? I'm going to go right 3. What's 3 times a half? 1.5. What's the next number I can plug in? 4. What's 4 times a half? 2. And then I'm going to put them on the same side. Same thing on the other side. So what happened to this graph? Look at the difference between these two. This one got wider, right? Let me make this bigger so you can see it. So it stretched where? Horizontally. So, in other words, if you have a whole number, what's it going to do? Stretch vertically. It's going to pull it up more, right? What about if you have a fraction? Stretch it horizontally. There you go. All right, let's go to page 32. I think most of us are already there. So this is being compressed horizontally, but it's also being stretched vertically. It's the same thing. It's the same thing. When you get to pre-cal, you'll learn they're probably going to want to be more strict, but it's the exact same thing. It's either compressing it horizontally and it's also stretching it vertically. I just like to use the same word every single time because I get a little confused. Like this one, it's being stretched horizontally, but it's being compressed vertically. So it's the same thing. Alright, where are we at? So all I wanted you to do here is what? Identify. So what? Here we go. What's this one? Constant. Why? Because it's a straight line. There's no slope whatsoever, okay? James, with me back? What about number 2? Absolute value. What about number 3? Very good. Make sure you know both words because the ACT loves to use either or. They want to make sure you know both of them, okay? Why did number 3, why did we call that one an identity or linear, but we called number 1 a constant? What's the difference?
Constant has a slope.
That one has a slope. There you go. All right, what about number 4?
It's identity or linear.
There you go. And number 5.
Absolute.
There you go. Okay, I am not going to write all of the next ones, so we're going to go over these together. Are y'all ready? Everybody ready? Get your pencils ready to go? All right, here we go. What's the very first thing it says to do? Name a paragraph. Here we go. Number 6, what's the paragraph?
Identity.
Identity or linear. Describe, so it says name and describe. So what's describe? Tell me to do.
Up 4.
Up 4. There you go. All right, what about number 7? What's the parent function? Absolute value. You can abbreviate ABS, then value. You can abbreviate. And what's it to do? Down 5. Very good. All right, number 8. What kind of function? Absolute value. What's the parent graph of parent function of absolute value? What's that?
Y equals x.
Absolute value of x. There you go. All right, so that's number 8. Absolute value. And what's it do? Right 2.
And up 3.
Perfect. Right 2, up 3. Perfect. All right, what about number 9? What's the paragraph for number 9?
Identity.
Identity or linear, right? What happens to this guy?
It's stretched
Stretches horizontally. Yeah. And it moves down 6. Perfect. Stretches horizontally or moves down 6. All right, what about number 10? What's the parent graph? There you go. 3 things.
Oh, reflect it over the x-axis.
What told you that?
The negative.
There you go. Where's the negative? In the front. I don't care that the 7 is negative. He's not what flips him upside down. The negative in the front is what flips him upside down, okay? All right, what else?
1 and down.
Where? Left 1.
Down
Perfect, perfect, perfect. Left 1, down 7. So 3 things. Flips it over the x-axis. Left 1, down 7. Yes, ma'am. Yes, if it's on the inside, that 1's on the inside, so you change the sign, which would be a negative 1, and negative 1 tells you to move left 1. Yep. All right, what about number 11? What's the parent function for number 11? What you got?
Identity.
Okay, hold on a second. What is it?
Identity.
Identity or linear? What you got? Yeah, because it's like y equals 5 in everyone's age. There's no, like, it's, well, there is a slope you should see those. But if you have, like, y equals 5, there's nothing that's ever going to make that 5 change. That's why it's constant. But if you have y equals absolute value of x, you can plug in numbers to that x and make that 5 change. That's why it's called constant. All right, number 11, that's an absolute, that's an identity or a linear, but what happens to it? Describe the transformation. Stretch vertically 5 and up 2, okay? Make sure you use that word dilation in there on your test, okay? It's dilated 5, which stretches vertically, and then that plus 2 moves it up 2. And then we are going to omit number 12. All right, here we go, next page. All right, same thing on 13. Name the parent function and describe the transformation. So what's the parent function on number 13? Absolute value. And there's 4 things that happens on this one. It goes up 2. Okay, so this means up 2.
Stretch vertically.
Okay, make sure you
Right
use
over the x-axis.
Make sure you use the vocabulary word. It
Dilate.
dilates 3, which stretches vertically. All right, what's the negative do in the very front?
It's reflecting over the x-axis.
Perfect.
Right 1.
It goes right 1. Very good. So it should be 4 things. It went up 2. It went right 1. It got dilated 3, which stretches vertically, and then it flipped or reflects over the x-axis. Are y'all okay? Easy enough? All right. And then here we go. What's the only thing it says to do on the last few problems?
Graph.
Graph. There you go. And on the back, it's the same thing. You got 5 whole problems. All right. Try those and see what you got.
Can I go ahead and just check one?
You finished with them? Yeah. Just keep that out. That way you can check your work. Okay.
Well, I think I already have yours.
You have one already?
Yeah.
Oh, okay. I didn't realize you had those. Good check. Anybody else wants to claim this homework up here without a name on it? One more over there without a name on it.
this?
Yep.
I haven't seen the video, so I just know.
Oh, that's right. Okay. So that's right. Are you okay on everything now?
Yeah, it's really easy.
You do Wednesday.
Alright guys, so let's check our work on 15 and 16. The plus 2 here on the outside told us that we were going to move up 2 from the origin. And then we absolute value, there's nothing that dilates it. So you're going to go out 1, up 1, out 1, up 1 on both sides. Alright, number 16, excuse me. That 3 is on the inside, so you have to take the opposite sign, and you're going to move left and right. Plus 3 tells you to move right 3. So that's why we move from the origin right 3. There's not a number in the front that's going to dilate it any, so you're still going to go out 1, up 1 on both sides. Alright, number 17. The plus 4 on the inside means you're going to take the opposite sign, so you move left 4. Negative 2 on the outside means you move down 2. There's not a number in front, so you're not going to dilate it any, so you just went out 1, up 1 on both sides. Alright, 18. The plus 2 on the inside tells you to take the opposite sign. That tells you to move left 2. Then the negative 3 tells you you're going to move down 3. Alright, now this guy in the very, very front means that instead of going out 1, up 1, it's going to flip upside down. So you're going to go out 1 and down 1 on both sides. Alright, and then number 19, last one. You're not adding or subtracting anything in the back. So you're going to start at the origin. Now this 4 tells you that you're going to dilate that. So instead of going out 1, up 1, you're going to go out 1, up 4 on both sides. And instead of going out 2, you're going to go out 2, and 2 times 2, excuse me, 2 times 4 is 8. So you're going to go right 2 and up 8, or left 2 and up 8. And you see that that stretched it vertically, or you could say that it compressed it horizontally. It's pressing it in horizontally. All right, and that's all we were doing in class today.